Okay, so this is homework 4, problem 2. And so we are given that g of x is equal to 1 for x is less than 0, 0 for x is between 0 and 1, negative x for x between 1 and 2, and negative 2 for x greater than 2. And so the corresponding graph of g looks like this graph here. And so it's important to use this graph because it's going to be very helpful for us in the future to find small f of y and big f of y. And this is the f of x that we were given. So this distribution will also come in handy when we end up drawing the graph in the future. And so we know a couple things right off the bat. We know that big f of y is bounded between negative 2 here and positive 1. This is the y-axis, so it's bounded between these two numbers. And so we already know that when y is less than negative 2, the probability is going to be 0. And when y is greater than or equal to 1, which is the maximum here, the probability is going to be 1. Because the max probability of the probability mass function has to equal 1. Okay, so we know also using the fundamental theorem that small f of y is equal to small f of x divided by the derivative of g of x. And since x here is, we are given that negative x, y is equal to negative x, so the derivative of negative x is just negative 1, but since the absolute value of that becomes 1, and then we have small f of x, but since x is equal to negative y, we input in negative at y, and so we're given f of x is equal to negative y. And so this will help us in the future. But just looking at this graph here, we know that there are 3 impulses, because if we try to flip this graph to the side, we see there's an impulse at here, at 1, impulse at 0, and an impulse at negative 2. So where x stays constant, so these are these 3 impulses. And so the corresponding impulse for small f of y, we have an impulse, like I'll go over how I got the value of these impulses later, but this impulse at y equals negative 2, y is equal to 0, and y is equal to 1. But from negative 2, from y is equal to negative 2 to negative 1, we see this line here, and this line corresponds to just small f of x of negative y, and we have that right there. Okay, so to find the impulse at negative 2, it's simply, since at negative 2, so you see it when y is equal to negative 2, x goes from 2 to infinity. So it's the probability of small fx of x greater than 2, but that is also equal to 1 minus the small f of x is less than or equal to 2. Small f of x less than or equal to 2, since the integral goes from integral of big f of x goes from negative infinity to 2, that is the same thing of just saying big f of x of just 2. So the area of this impulse at y is equal to negative 2 is simply just 1 minus big f of x of 2 times where the impulse is. In this case, since the impulse at y is equal to negative 2, it's just the impulse function of y plus 2. Okay, so the impulse function, the area of the impulse at y is equal to 0 is simply just the area of between this area here, from 1 to 0. So it's simply just the integral of small f of x from 0 to 1, which is equal to big f of x of 0 to 1, which is simply just f of x of 1 minus f of x of 0. So this is the area of the impulse function here at y is equal to 0. Now finally, the impulse function at y is equal to 1 is simply for x is less than or equal to 0. Now f of x less than 0, so we have that right here, is simply just the integral of negative infinity to 0 of small f of x, which is equal to big f of x of 0. Now graphing the small f of y is really simple. You just graph your impulse functions at negative 2, 0, and 1. You should probably also label their corresponding areas This is not the height, by the way. This is simply just the area of the impulse function. That's important to realize. And elsewhere, where there's no impulse function, it's equal to 0, except between -2 and -1, where it is defined where it is going to be small f of x of -y. And now this is where this original function comes in handy. We have small f of x. This is what the graph looks like. And so f of x of positive x would simply just look like this graph here. But since it's negative, we have to take what it looks like from here. This graph looks almost even, so there's not too big of a difference. But now we take what would look like this slope here, and then we simply just graph it here. So this is the graph of small f of y, where we have impulse function -2, 1, and 0. 0 elsewhere except for -2 and -1, where it's given by small f of y of -x. Okay, so moving on to get big f of y, we already know since the big f of y has to be bounded between -2 and 1, so we already know that for y is greater than or equal to 1, since here y is either going to be greater than or equal to 1, it's going to be 1, because the probability mass function cannot be greater than 1. It has to equal 1 to be a valid probability mass function. I'm sorry. And it's going to start off at 0 for when y is less than -2. I'm sorry, that's supposed to be -2. So -2. And then between there, it's simply just going to be the integral of small f of x, which is big F of x of y, from -2 to -1. And so drawing this becomes very simple, because the area of the impulse function, small f of y, just becomes the height at -2, where the impulse would have been on big F of y. And so we start off at -2, because it's 0 before that. -2 jumps up a height of the area of the impulse function at -2 for small f of y, and that's equal to 1 minus big F of x of 2. And then we have the slope here at big F of x of y goes up until -1, and then we notice from -1 to 0, there is no change given by small f of y. And so that graph stays constant until 0, where we hit another impulse and it goes up by that similar height of the area of the impulse function at 0, which is f of x of 1 minus f of x of 0. And then we continue on, because nothing happens, until it hits 1. And then it increases again with the height of the impulse function at 1, which is f of x at 0. And then it continues on, because it hits 1. And for y greater than going until as long it has to go, it will stay 1. So this is the graph of big F of y. This is the graph of small f of y. And that is the answer to number 2.